morning, good afternoon, or good evening, depending upon where you are. My name is Ram Posham. I'm an enterprise architect with Oracle for over 20 plus years, and my specialization is on the data platform. So that includes Oracle database, Oracle engineered system, Exadata, and related technologies like GoldenGate and data integration, like Oracle Data Integrator, and so on. Primarily, it's the data platform. So today, I'm going to be presenting on Oracle Maximum Availability Architecture, how you can deploy Oracle database to deliver maximum availability. That's going to be the focus of this presentation. I think most of you know this, right? If a component can go down, it will go down someday, right? Probably you know who said this. This is not my quote, but this is Murphy's Law, right? So in any system, you got many components, and if a component can go down or fail, it will fail someday. And the goal of this presentation is to help you to minimize, mitigate, and eliminate the risk or the damage that is caused by outages to any component in the system, right? If a business application is down, it's going to cause loss to the business. It could affect the reputation of the company and so on. So by the end of this presentation, you will know what is the best way to deploy Oracle database to deliver maximum availability. Here is the agenda. I'm going to be spending a minute or two on the impact of downtime, just sharing with you some of the research findings by Gartner and IDC and so on. Then I will briefly describe what is maximum availability architecture and get into the building blocks, the technologies, the engineered system that Oracle recommends to deliver this maximum availability. Then I will get into what some of the 4 maximum availability architecture, reference architectures that Oracle provides. Again, there could be many architectures, but this is this reference architecture should meet almost all the requirements of customers. And then at the end, I will map the service levels to these recommended architectures. So here is a slide based on Gartner research and also Forrester research. Actually, you can see here at the bottom. And it is substantial. See, the cost of downtime could be as much as $350,000, which is huge, correct? So you need to deploy, design a system, architect a system such that the downtime is minimal or there is no downtime. And also the second one is the average amount of downtime per year is 87 hours. So, this gives you an idea. And here, look at this one. If the data center is down, it can happen because of hurricanes or earthquakes. It's possible. If you don't have a disaster recovery solution, the downtime could be so much, right? So one has to consider all these aspects when they deploy IT systems. Here is a survey from 2019 Oracle Open World. Basically, this survey was conducted by interviewing the database administrators, database architects, the folks who manage Oracle databases. So their biggest pain points, they said, was upgrades. Yes, when you want to upgrade a database, it's not trivial. And patching is another painful activity the DBAs go through, right? And high availability. When the system goes down, how to bring it up within a short period of time. So these are all very, very important to note, all right? And you can learn more about this survey. I provided the link here. So very quickly, what is maximum availability architecture, right? So it is an architecture for database resiliency within and across data centers. That's what Oracle's MEA is all about. And the goal of this architecture is to minimize or eliminate planned and unplanned downtime. So when we talk about downtime, we include both. So the MEA goal is to minimize the downtime for both these events, planned and unplanned events. So you are going to have an architecture diagram or an artifact where you show how your database systems are going to be deployed, right? How they are going to be deployed. And the next one is it includes these technologies. When we talk about the MEA, these are the key technologies that are important for delivering MEA. Real application clusters, which I'm going to talk about briefly, Data Guard, flashback technology, and recovery manager, which is backup and restore solution. Very quickly, flashback is a very cool technology that you probably know. If there is a human error, let's say you run a job, the job starts at 10 o'clock and 12 o'clock you realize something went wrong and you need to rewind the database, you can do that. So that is using this technology called flashback. And the next one is, the database infrastructure is highly available. It's great, but how do we provide application continuity? It doesn't matter how highly available your database infrastructure is, but if the application is not leveraging it, if the application is not available, it doesn't matter how highly available your database is, all right? Oracle also, as part of MEA, we recommend engineered systems like Exadata, Oracle ZFS, and ZDLRA, Zero Data Loss Recovery Appliance. Now, this makes life of DBA system administrators easier. Instead of you building IT hardware, software, and integrating them, Oracle has come up with this engineered systems, which is one of the most popular products around the world. Just deploy it on the third day, you can start using it as a database mission. The next one that we include as part of MEA is reference architectures, as I briefly mentioned in the beginning, and I'm going to talk about that, and a lot of books and white papers and blueprints using which customers can deploy MEA architectures. And this is based on more than 30 years of experience that Oracle has gained by working with some of the large customers that run mission-critical systems. So let's talk briefly about the building blocks. So I'm going to be focusing on these 4 building blocks today: a RAC, and also transparent application continuity, Data Guard, and GoldenGate. So let's jump into that. So real application clustering technology was introduced way back. It started with Oracle 8. Then in Oracle 9i was the first time when it was built using the interconnect technology, the high-speed interconnect between compute servers. So very quickly, it's based on shared everything architecture. So you've got one copy of your database, and your database is available to access from multiple nodes. So you can access it from multiple database servers. All right. And the idea is you can scale it horizontally. If you need more capacity, you just need to add another compute server, maybe another 2. So you can keep on adding servers to support scalability. So horizontal scalability. And you can add additional storage too online if you want to have higher capacity. There is a concept of services. The service is nothing but a grouping of database instances. So when let's say you're running a database called sales on in this database, you got sales 1 instance here, sales 2 here, and sales 3 instance here. So sales.oltp, what you're saying is whenever I ask for a connection to this service, sales.oltp, you're saying connect to sales 1 and sales 2 instance. Similarly, if I ask for a connection to ship.oltp, what you're saying is connect to those instances, in instance 2 and instance 3, sales 2 and sales 3. That's what it is. And scan is a single client access name. Think of that as a global virtual IP. So whenever you want to connect to the database, you provide scan, you provide the service name. All right, that's how you connect to the database. So Oracle RAC provides scalability so you can scale horizontally by adding compute nodes or storage. It also provides high availability. So in the event you lose a node, your database is still available on the surviving nodes. And the services automatically fail over. So that's another big thing. And another benefit is zero downtime patching. So let's say you're on 19C, 19.5, tomorrow there's a 19.6, you can patch the database one node at a time. So that means on one node, you shut down the instance, patch the Oracle home, then you bring it up, and then you go to the next one, and so on. So you're applying the patch in a rolling fashion. There is also what's called messaging infrastructure, which I will talk in just a minute. So as part of the clustering software, there is something called ONS, Oracle Notification Services. This is the piece of software that monitors the health of Oracle database, all the instances, and the services. So if an instance goes down, it can send a message to any application, right? If it comes up, it can send a message. Similarly, it also sends what's called load balancer advisory messages. So it says, oh, sales.oltp, you connected to instance 1 and instance 2. Instance 1 is so much loaded, instance 2 is so much loaded. Those kind of messages are also sent to whatever client you want. And those messages are called FAN, Fast Application Notification. So whenever there's an event on the database side, the messages are sent to any client. RAC provides another benefit, number 3, which is performance. So let's say you run a query on 2 nodes, it takes 10 minutes. If you run it on 4 nodes, it can potentially take 5 minutes because of the parallelism. The parallelism gets spread across all the compute nodes if you want. So that's the third benefit of RAC. The fourth one is workload management, where you can have different types of workloads on the same database, and you can spread the workloads on different instances. So as you can see here, sales.oltp runs on instance 1 and 2, ship.oltp runs on instance 2 and 3. So you can have ETL backup jobs spread across different instances. So that's what's called workload management. All right. Now, it doesn't matter how highly available your database is, as I said, the application server has to leverage that. So here is an application, let's say a Java application. You got an application server, and to connect to the database, you need the driver. So if it is a Java application, it has to be a Java driver. You will be using connection pools. You don't want to have thousands of connections to the database. So you want to use some kind of connection pool mechanism. So what happens is when you ask for a bunch of connections to the database through connection pools, they are spread across those services, right? That's how you spread the connections. Now, in the event you lose an instance, the connections will fail over to the surviving instances automatically based on how you define your services, of course. All right. The most important thing to note here is whenever there is an event, ONS sends a message to the application server, and the application server takes the necessary action. All right. So it leverages that message. Oh, okay, the instance went down. Now I need to close all those connections, clear the connections cache, and connect and make new connections to the surviving nodes. That's what the connection pools do. Oracle database provides all these drivers. If it is Java, you get the Java drivers. If it is OCI, you get the corresponding drivers, and also the libraries for the connection pools. So you get all that, and you can get more information at this link. All right. So the thing is, when the instance comes back up, the connections will be again automatically rebalanced. That is the thing to be noted. Now, I want to highlight the importance of WebLogic Server for Java applications. So if you're running a Java application, WebLogic Server will deliver this application continuity. We call it actually the transparent application continuity if you're running the database on 19C or 18C. So you can run your application, if it's a Java application, on JBoss or Tomcat. But with WebLogic Server, you get many additional benefits. So you can see the matrix here. So for example, of course, the fan events, the understanding the fan events, failing over the connections, failing back the connections, all that any application server can provide as long as they are using the Oracle JDBC driver and the Oracle UCP, Oracle Universal Connection Pools. But if you are using WebLogic Server, it does many other things. For example, transaction manager integration. So if you're using a transaction manager, WebLogic Server provides you automatic integration for that. And one of my favorite things is here, shrinking and shrinking the connection pools and expanding. All that, that's done here. And also there is a security that is you can have client ID on the connection and identity pooling you can have. And also you can see the rest of the benefits on this slide. Okay. Again, those of you who are managing application servers, you will understand this. But the simple message is, if you use Oracle WebLogic Server, the configuration of the connection pools, usage of the latest drivers, all the required libraries, they come out of the box. You don't need to do anything. You just define the connection pools and start using in your application. That's all. Whereas if it is JBoss or other application servers, you have to make sure that you're using the latest JDBC drivers, your application supports the latest JDK, and on top of that, you don't get all the benefits that the Oracle WebLogic Server provides. By the way, there is a functionality called Oracle WebLogic Server Active Grid Link, AGL, for WebLogic Server. So that comes, that is part of our WebLogic suite. And so you get all these benefits because of that. So you can learn more about it by reading more on Active Grid Link for RAC. Okay. Now let's talk about this application continuity. What do we mean by application continuity? So let's say you have an application and you're running it against a RAC database. All right. And what happens when the communication breaks between the database server and the application server? So let's take an example. Let's say you're an end user, you submit a transaction, and the transaction goes through the application server. The application server sends all the DMLs, DTL, whatever, all those changes are sent to the database and they are committed. Great. And then what happens is, before it acknowledges, before the database sends the message to the application server, let's say you lost a connection, right? So it is possible that the transaction was committed, the message was not sent. It's also possible that it was just about to commit the transaction and something happened. Both are possible. Those are the edge cases. So then what happens is you get an error saying that, obviously the application server gets an error, and then the end user is going to end up resubmitting the transaction, which can result in duplicate transaction. So imagine you're doing a bank transfer. That's a very dangerous situation. You don't want to have that. So starting with 18C, what we have done is what's called transparent application continuity. So the way it works is this. So you send the transaction, right? And so then it goes to the database, and the transaction fails before or after the transaction, before or after the transaction is committed, right? Now, both are possible, as I said. Now, this JDBC driver detects that error, and when you use the latest JDBC driver and you run against Oracle 18c or higher databases, what this does is it checks, hey, database, I sent you a transaction. Did you commit it or not? So that then the database will let the application server know what happened to the previous transaction. So after the connection fails over to the surviving instance, that's what happens. So the application server sends a message to the database server to find out the status of the previous transaction, right, or transactions. Then there is something called a transaction guard, which is a feature of 18c and above, and it maintains the state of that particular transaction. So it says, hey, the transaction is committed, then the application server doesn't have to do anything. But if the database says, nope, the transaction was not committed, then the application server is going to resubmit the transaction, and your application end user will not even know about it. So that is the best part. So your transaction will be committed only once inside the database. There will be no duplicate transactions. And it will also reduce the code for error handling. You don't have to handle these kind of edge cases in your application, all right? So that's what happens. And so we'll submit all the inflow. If it failed in between a transaction, then it's going to resubmit the in-flight transaction to the database server, right? And the user gets a success, and it will continue. So there will be no duplicate transaction inside the database. Again, you can learn more about this in this. There are a couple of white papers here, excellent white papers. They provide you more details. Now, to achieve transparent application continuity, you have to use the 19C and the 18C JDBC drivers. So these are the drivers for Java applications, and there are, if you search for Oracle JDBC drivers, you can find them. All right, here is a link there. And so those are the JDBC drivers. Here is the interoperability matrix. So if you use Oracle JDBC driver 19C, you can go against 19C database, 18C, 12.1, 12.2, and also 11.204. And if you use 11.204 JDBC driver, you can go against the latest database 19C all the way down to 11.204 database. So you can see the drivers are downward compatible as well as upward compatible. So this is the best part. Now, if you want to have transparent application continuity, you have to use the 19C or 18C JDBC driver, and you have to go against 19C database or 18C database. So that is a combination, basically, if you want to have transparent application continuity, the one that I just described a minute ago. All right. So that was about Oracle and transparent application continuity. Now let's talk about Data Guard. Right? Data Guard is it's a raw technology that has been there from Oracle 7 days. It's almost 25 years now. So a Data Guard or a standby database is essentially a transactionally consistent copy of your primary database. All right. So on day one, you instantiate it, and from that point onwards, you ship the redo. As you're doing transactions, the redo is shipped to the standby database, and the standby database applies. There's a process called managed recovery process that reads the blocks from the standby redo logs and applies to the standby database. And starting with 12C, we have something called active data guard, right? which means actually 12C or actually it's from 11G. Sorry. So you can use this standby database infrastructure for reporting workload. In fact, from 19C onwards, you can do some of write workload also on the standby database. So when you write to the standby database, actually under the covers, it shifts the redo to the primary database. But that's a separate topic. We don't have to spend too much time on this. So what is happening here is from the primary database, you are shipping the redo to the standby database. Now, the standby database can operate in two modes, right? So whenever you do a commit, what happens is the commit is going to wait. If you are running it in asynchronous mode, it's not going to wait for the redo to be written into the standby redo logs. It's not going to wait. Whereas if you operate it in synchronous mode, the standby database, let's say it's within a close proximity, 30 to 40 miles radius, and you can afford to do it in synchronous mode. When you do that, and let's say you issue a commit, application will continue only after the redo is successfully written into the standby redo logs. Until then, your application will not continue. The advantage of that is you will have zero data loss because your application will make sure that the standby has the latest redo, right? So you don't miss a single byte of transaction when you use in synchronous mode, all right? The most important thing to note here is your standby has to be within 50 miles radius or maybe 30 to 40 miles radius. Otherwise, you can encounter latency issues. Technically, there is no reason why you cannot run it in synchronous mode, but if it is more than 50 miles away, then you can get into these latency issues and your standby performance can get affected. The next technology I just want to briefly touch upon is GoldenGate. So GoldenGate works slightly differently. So you got a database here, you got another database here. They could be both Oracle database, or this could be a different version of the Oracle database, or it could be a non-Oracle database. So the way it works is there is a process called capture as part of GoldenGate. It reads the redo log files and it generates what's called trail files. So it says, hey, so-and-so record was changed from X to Y. So the before change and after change data is written into these trail files. It's a human readable file unless you encrypt it. And there's a process called pump, which ships the trail files to the target site. And at the target site, then you got a delivery process, all right? Basically, it's going to read the trail files and apply to the database on the right side, all right? And that is done using SQL. That is, it's at the logical level. Whereas the data guard was at the physical level. You are reading physical blocks and applying or writing the blocks. Whereas here, you are reading the trail file records and basically running a SQL command against the target database. All right. Now, it is possible you may be running bidirectional replication. In the case of bidirectional replication, just reverse. So when you write to this database from an application on the right side, it's going to generate the redo, and there's a process which reads the redo, and then it just repeats, the same thing, generates the trail files, and the trail files are shipped to the left side, and there's a delivery process. So that's how GoldenGate works. It's very simple, straightforward architecture. All right. Of course, you have to make sure that your application supports this bidirectional replication. There are things like conflict detection and resolutions you have to take care of. Now, let us put all these building blocks together and build these what's called reference architectures. So Oracle has created these four reference architectures called bronze, silver, gold, and you can use this to meet different service levels. So very quickly, what is bronze architecture? Bronze is very simple. Basically, what we're saying is you run an Oracle database in a what's called Oracle single instance database on a cluster. All right, it's known as Oracle Restart. So restart is a single instance database running on top of Oracle grid infrastructure, right? So you got clusterware, you got ASM, all that. On top of that, you can create a single instance database. The idea is if the database goes down on a particular node or an instance, it can start up on one of the other nodes in the cluster. But at any point of time, the database is running on only one node. All right. So here in this architecture, you've got your application here, you've got your database here. Think of this dotted line as one data center. This is another data center, second data center. And what we are saying is you take backup of your database onto a local appliance. We are recommending Oracle Recovery Appliance, but you can back up to any storage. But our recommendation is Oracle Recovery Appliance, which is called Zero Data Loss Recovery Appliance, ZDLRA. It has got a lot of features. I'm not going to go into that at this point. And what we're saying is from here, you replicate to a remote site. And in the event you lose this database infrastructure, then you rebuild this and restore it, and then bring up the database. It can take any time, depending upon what happened to the infrastructure. It can take minutes, hours. It could take probably days also. If any catastrophe happens, it can take days too. The next one is Silver architecture, where instead of running the database on a single instance, Oracle restart, what we are saying is run a RAG database. Basically, run it on multiple nodes. So in the event you lose one node, your database is still available on the other node. That's number one. So we are talking about RAG database. The second one, what we are recommending is run it on Exadata. Exadata is an engineered system. It makes your life easy. You don't have to deal with all the clusterware, the storage management. It's an engineered system. So you just run your databases. It's a very powerful technology. You get best performance. Oracle has done a lot of optimizations in this system. So anyhow, so that's Exadata. We are asking to run RAG database, and here also 2 data centers, and you back up to the local appliance, and then you replicate to the remote appliance. And in the event you lose this, then you restore it, and then you bring up your database. So again, it can take hours, it can take days, depending upon what happened in the data center one. All right. So it doesn't give you the highest availability, but some customers can use this. These are some of the most popular architectures that are used by Oracle customers. So what's called gold architecture? If you look at Oracle white papers, when we say gold, it is having a primary database in data center one and having one or more standby databases in other data centers. That's the definition of gold architecture. So this is data center one, or we call it region. And within region, actually, you can have multiple data centers. So AD1, availability domain, think of that as one data center. This as another data center in a different region. So what we are saying is have a primary database and a standby database in a different region, probably 1,000 miles away, and run the database here in RAC, here also in RAC, but this is a standby database, and you do asynchronous log shipping, right? That's what you do. And your database application is running here, and you also have the infrastructure here in the second data center. In the second data center, you can run, if it is an active data guard, you can run reporting workload, right? This is read-write here. So in the event you lose the primary database for any reason, you can bring up your standby database in read-write mode and run your workload. So your downtime is significantly minimized here. There is still some downtime, maybe a couple of minutes, but that's still some amount of downtime. Some applications may not, some customers may not like that much downtime, right? So that is the solution here. And now, then the next one is, I would like to call it Gold Plus. You will not find this architecture called Gold Plus in Oracle white papers. I named it as Gold Plus. Here I'm talking about 2 standby databases. So here I'm saying you got 2 data center, 2 regions, region 1 and region 2. In region 1, you got data center 1 and data center 2. And in data center 1, you got a primary database. And within close proximity, within maybe 15, 20, or 30 miles radius, you got another data center, and you run its first standby database. In the remote data center, you run the second standby database. Now, note here, this database is running in the asynchronous mode, this standby, and this one is running in the asynchronous mode. So when I say synchronous mode, right, you understand. So whenever there's a transaction committed here, the redo is written here, and that is guaranteed, right? That means you don't have any data loss. In the event you lose this database, you have all the data sitting here. All right. So your application is running in both the data centers, and in this data center, you are doing read workload, you're doing read write, and you're doing read workload on this one. Okay. So this gives you the highest, not the highest, this gives the best availability. And you see this one, it could be just seconds. So in the event you lose this primary database, this becomes your new primary. And that's something called data guard fast start failover. So you can configure in such a way that if there is a hiccup in the primary database, this takes over that role as a primary database. And so you're highly available, and this is automatic. All right. And when that happens, then this becomes your new primary, this becomes your standby 1, this becomes your standby 2. All right. So that is how a Gold Plus architecture can reduce your downtime significantly. All right. This is the ultimate architecture, what's called the Platinum. So in Platinum, you got again 2 regions, but here we are talking about 4 data centers. So data center 1, data center 2, 3, and 4, right? And we are having 2 production copies. So this is primary 1 and this is primary 2. So 2 production copies, and you're doing bidirectional replication using GoldenGate. And the assumption here we are making here is actually this should be read write. This is read write. I'm sorry. This says, let me go here. Let me annotate here. This is even here, this is read write. So this is read write, this is read write, and you're doing bidirectional replication here, as you can see. All right. And each production copy of the database, this database has got its own local standby. This database has got its own local standby, and this is running in synchronous log shipping mode. So what that means is you have 0 data loss. So you see, if you lose this database, you got your database running here, and you have 0 data loss. If you lose this, you got your database up and running here, and again 0 data loss. If you lose this entire data center, you got your application running in the second region. So at any point in time, your database, your application is available. So that is 24/7. So with Platinum architecture, you have 0 data loss and you got 0 downtime. That's what you get with Platinum architecture. Now let's talk about how these architectures minimize your downtime, both for planned and unplanned events. So here I got 2 regions. I just put them in a vertically up. So this is region A, this is region B. You got a prod copy here, production 1, and its local standby. This is production 2 and its local standby. And we are talking about a local backup here, local backup here. And you see, we are doing synchronous log shipping. Now I'm going to show you how you can do patching in a rolling fashion. All right. So we're talking about 2 regions here, and in each region you got 2 data centers, basically 4 data centers total. All right. So now let's talk about how we can apply the patch in a rolling fashion. So let's say you're on 19.5, you want to go to 19.6, right? This is V1 is 19.5, All right, everything is on 19.5 now. Now you want to go to 19.6. So this is V2, 19.6 is V2. So what you do is, because the patch is rolling, you can apply it in a rolling fashion, and this is a standby database. What you do is you shut down one instance at a time, you apply the patch, bring it up, and that's how you apply the patch on the standby in a rolling fashion, right? Same thing, you can do it here also concurrently if you want. Then after that, what you do is do the same thing, apply the patch in a rolling fashion on prod A and prod B, right? So that's how you can apply the patches. And then you see, after the patches are applied to the binaries, there is a last step, which is called data patch. You have to upgrade the dictionary, the metadata. So you just run, if you're on 19C or 12.2, there is a script called data patch. You run that, and it's going to update the metadata of the database. So it's fairly simple. Patching is very simple. Then let's talk about the system failure, right? What happens if you lose a node? So let's say you lost the production system. You lost the actual accelerator, complete mission you lost. Then this becomes your read-write copy instantly, and it will continue. Your application still continue, and this becomes, then what you do is you reinstate this when the mission is repaired. You fix the problem, and then you reinstate the production, and then this becomes your new standby, right? And you didn't lose any data because of the synchronous log shipping. So this becomes your new standby. This is your new primary, and you can run it as long as you want. There's no need to switch over to this one. But in case you want to switch over to the original primary, you can do that. Just one simple command in Data Guard. So that's how you can mitigate risks from system failures. And you do the same thing if some other system goes down. You get the idea, right? In this kind of architecture, there is no real downtime. It's a platinum, obviously. So you have zero downtime. Then the next one is, let's talk about the MAA Gold Plus architecture. So here you have only one standby. You don't have two standbys. So for the first prod copy, here you have one production copy. The region B, in region A, you got standby 1, and this is standby 2. Actually, this should be this is standby 2. My mistake. Standby 2. And so what you do is, for patching, you apply this. So here you can see AS2. This should be AS2 here. Sorry about that. So you patch this standby. You patch this standby. Okay. Then after that, you patch the primary database here. All right. And then finally, you run the DB data patch script on this production database, and then all the metadata will be updated on the primary database and also on all its standby databases. So that's how you can apply the patch in a rolling fashion for Gold Plus architectures. So in Gold Plus, you got one production copy and two standbys, standby 1 and standby 2 here. So, and you apply the patch in a rolling fashion. Now let's talk about system failure for Gold Plus architecture. So you got prod for production database, primary database, standby 1, and this is standby 2. Okay, and this is this should be AS actually, and this is a read workload. All right. So what you do is, if you lose this database for any reason, this becomes your read-write copy, right? And this becomes your standby. This becomes your standby. And then you reinstate after you fix the problem. This becomes your standby 1, right? This becomes your AS. So this becomes standby 1. This becomes your standby 2, right? This is your local standby. What you see is your local standby. And this is your actually production database. This is primary. Okay. So this is actually this should be primary. Okay. Okay. Then you can continue to run on this as long as you want. But for any reason, if you want to switch over to this one, you can do that. So when you switch over back to this production, then you're back to the original state. So this is your local standby. This is your remote standby. This should be a read workload, not read write. All right. So that is the Gold Plus architecture. So you can, and now you understand how you can manage or mitigate the risks from patching and system failures. All right. Now let us look at the service levels and map them to the recommended MAA architectures. All right. So here, this is from a large customer who has actually 7 tiers. So tier 1, they define it as 0 downtime and 0 data loss. Okay, so that's what tier 0 means. Tier 0 means 0 downtime and 0 data loss. Tier 1 means they can afford to be down for less than an hour in a year for both planned and unplanned downtimes. And they can lose maximum 15 seconds worth of data. That means they should be able to restore the database up to the last 15 seconds, right, before the system failed. And tier 2, it is they can be down for less than 4 hours, and they can lose up to 60 seconds, and so on. I mean, nobody wants to lose more data, right? So that's the way they define. Now, Oracle's recommendation would be, if you want to have 0 downtime and 0 data loss, obviously you go for the Platinum architecture, where you got 2 production copies, and each production database has got its own local standby. For tier 1, where you're saying, yep, they can be down for an hour, less than an hour in a year, and I'm willing to lose some data, then what we are recommending is Gold Plus and transparent application continuity. Actually, even for Platinum, I should say, there is a need for transparent application continuity. I mean, transparent application continuity you have to use for every architecture, that because that's the only way you can get high availability and business continuity, right? Transparent application continuity gives you the continuity of your service, whatever that service is that is talking to Oracle database. So your database may be highly available, but if your application is not available, it's no good. So transparent application continuity is important for all the tiers. You can learn more about MAA at Oracle. So you can search on Oracle MAA. You can get many hits on Google, so you can do that. All right. So that's a quick overview of Oracle MAA. And if you have any questions, you can contact me. And my name in the beginning is Ram Posham. And so you can contact me at ramulu.posham@oracle.com. Okay. That's my email ID, ramulu.posham@oracle.com. Thank you very much, and you have good rest of the day. Another